Our video today is going to be about the topic of stoichiometry, specifically the limit and reactant types of calculations. What we're going to be looking at is this example reaction here. So in this reaction we have aluminum oxide solid reacting with hydrogen chloride gas, and it produces water and aluminum chloride. This is a neutralization reaction. When it's balanced, you'll see that for every 1 mole of aluminum oxide, you need 6 moles of hydrogen chloride gas, and you will create 3 moles of water and 2 moles of aluminum chloride. This is just the stoichiometric ratio. These aren't actual amounts. So if we have a specific scenario, it would involve us measuring out each of our reactants so that they can actually react together and create the products. So what we have here is we have 25 grams of aluminum oxide in this example, and we place it in the cylinder that contains 36 grams of HCl gas. When these two are mixed together in the same container, they will begin to react, and they will continue to react until we run out of one of these chemicals. So as they react, you will be making water and aluminum chloride, and the aluminum oxide, the 25 grams, will start to decrease in quantity, and the 36 grams of HCl will start to decrease as they break the bonds that they originally have and create the water and aluminum chloride. Eventually, you'll run out of either hydrogen chloride or aluminum oxide. But looking at these masses, we can't figure out right now which one we run out of. And so this is where stoichiometry is involved. And stoichiometry is just when you compare the ratios of chemicals within a reaction. And so here we have the two chemicals in mass, but what we know is that we need a 1 mole to 6 mole ratio. So we're going to do some calculations and try to figure out what we run out of. Is it going to be the 25 grams of aluminum oxide, or is it going to be the 36 grams of HCl? So in order to do this problem, we need to start with our measurement. So we got to think about normal kinds of calculations that we've been doing. So if you have a measurement, what we do is that is our starting point, and we try to figure out how much of something else we have or need or make. So what we are going to do first in step number 1 is we're going to calculate the mass of one of our products. And I'm just going to choose one of these two products. So our two products are aluminum chloride and water. So I'm just going to choose the aluminum chloride. You could also choose water, either one. But you want to choose one of them. So we're going to calculate the mass of aluminum chloride that can be produced. So we start with our measurement. So here's our measurement. And we want to figure out, if we have 36 grams of HCl, how many grams of aluminum chloride are produced. In order to do this calculation, we have to figure out the comparison between hydrogen chloride and aluminum chloride. That's the stoichiometry. Those are the coefficients. So our coefficient for HCl is 6 moles. And our coefficient for aluminum chloride is 2, so that is 2 moles. And so our ratio between HCl and AlCl3 is 6 moles of HCl to 2 moles of AlCl3. But we see we have grams of HCl and we want grams of AlCl3. So to go from grams to moles of any substance, you use its molar mass. So the molar mass of the aluminum chloride, 1 mole of aluminum chloride has a mass of 133.341 grams of aluminum chloride. For HCl, 1 mole of HCl has a mass of 36.4609 grams. So this is going to be one of our conversion factors. This here is going to be another conversion factor, and this one's going to be another conversion factor. These are going to make up the steps of the stoichiometry calculation to get us from 36 grams of HCl and figure out how many grams of aluminum chloride we can make. So to do this calculation, we are going to take our measurement, which is our 36 grams, and we are going to get rid of grams of HCl. And so to convert from grams of HCl, we need to cancel grams of HCl. And so we're going to put on the bottom of our first conversion factor grams, so that grams of HCl will cancel. 36.4609 grams is the same thing as 1 mole of HCl. So this gives us moles of HCl. Now that we have moles of HCl, we can use our coefficients to convert from HCl to moles of AlCl3. So moles of HCl will cancel. These are the coefficients. Then we need grams of AlCl3. So we want to cancel our moles of AlCl3 and get grams of AlCl3. So our units are going to cancel as we multiply across the top and divide by all the numbers that are on the bottom. So if you use a calculator to do the math, it will be 36 grams times 2 moles of AlCl3 times 133.341, which is the molar mass of aluminum chloride. Then you're going to divide by the molar mass of HCl, and you're going to divide by the 6 moles of HCl. So I'm going to round it to 4 digits because this here is 4 digits, and I get 43.89 grams of AlCl3. And that's the amount that's produced by the 36 grams of HCl. So if we had 36 grams of HCl, which we do, we could make 43.89 grams of AlCl3 if all of this 36 grams of HCl reacts. So these are going to be our amounts for our first measurement. So this will be 43.89 grams of AlCl3. But we also have a second measurement. We also have the amount of aluminum oxide. We have 25 grams of aluminum oxide. And this also is reacting and will produce a certain amount of each of the products. So 25 grams of aluminum oxide can produce how much aluminum chloride? So once again, we've got to look at the ratio between these two substances. So we have 1 mole of aluminum oxide can produce 2 moles of aluminum chloride. That's going to be our stoichiometric ratio between those two substances. We need molar mass of aluminum chloride again. So the molar mass, 1 mole of aluminum chloride has a mass of 133.341 grams. And because aluminum oxide is in grams, we need its molar mass. And the molar mass of aluminum oxide, 1 mole of aluminum oxide has a mass of 101.961 grams. So these three are going to make up the conversion factor that allow us to determine what mass of aluminum chloride we can create if the 25 grams of aluminum oxide react. So we just need to organize it so that our units will cancel. So I'm going to start with our measurement, and our measurement is the 25 grams of aluminum oxide. And so we're going to need to cancel grams of aluminum oxide. So we are going to use the molar mass of aluminum oxide. So on the bottom of the first conversion factor, we are going to put the molar mass of the aluminum oxide, 101.961 grams. And on the top, we are going to put the 1 mole of aluminum oxide. So this will allow us to cancel the grams of aluminum oxide. Once we're in moles, we can do our mole-to-mole ratio between the aluminum oxide. So our coefficient for aluminum oxide is 1, and our coefficient for aluminum chloride is 2. The 1 to 2 ratio. And then to convert to the mass of aluminum chloride, we have to cancel moles of aluminum chloride, and we do that by using the molar mass of aluminum chloride. So we're going to multiply across the top and divide by the bottom. All of our units are going to cancel except for grams of aluminum chloride. So it will be 25.00 times 2 times 133.341 divided by 101.961 and then divided by 1 divided by 1. Okay. When you complete this calculation, you get 65.39 grams of aluminum chloride. So if we take our two answers to our calculation, if we use all 36 grams of the HCl, if we use all of it, we can make 43.89 grams of aluminum chloride. If we use all 25 grams of the aluminum oxide, we can make 65.39 grams. of aluminum chloride. These two chemicals are reacting with each other to create the aluminum chloride. So we can't make both masses. So what these numbers allow us to figure out is the 43.89 is using up all of the 36 grams. So once you create this much of this product, you're going to use up all 36 grams. Or if you use all the 25 grams, you can get up to 65.39 grams. Well, this is a much bigger mass. So you can't produce this much. Because once you get to 43.89 grams, you have used all of the HCl. And so both of these need to be present to create this product. And so if we create 43.89 grams of this product, we're reacting aluminum oxide and HCl, but once we reach this mass, we're not going to have any more HCl left. We're going to run out. And so the limiting reactant for this problem is going to be the HCl. What that means is HCl will be gone completely, and there'll still be some aluminum oxide solid that remains. So this one is called the excess reactant. So we're starting with 25 grams of the aluminum oxide. Some of that will get used up, and we'll do that, the rest of the calculations in the next video.